In the previous video, we saw the gradient of a function. Now we are going to see the divergence of a vector, or the divergence of vector field. We will continue seeing the nabla operator. So we already talked about nabla being the vector partial derivative with respect to x, partial derivative with respect to y, and partial derivative with respect to z, or we can put it as partial derivative with respect to x in the I component plus partial derivative with respect to y in the y component, or times the unit vector y, plus partial derivative in the z component times the unit vector k. Alright, we already saw the gradient, that is nabla times a function, and this was how we passed from a function to a vector. Now let's say that we have a vector. Vector v is equal to some component x, y, and z. Here let me put some f of x, y, and z, h of x, y, and z, and j of x, y, sorry, e here and h here. And let me put as an example 2x plus y, 3y squared plus c, and 8c plus 2 square x, for example. Now, the divergence of a vector is the nabla operator dot the vector. So we are just doing the dot or scalar product of two vectors, the vector nabla and the vector v. So we will just get a number, for that's called the scalar product. So this will be, in this case, well, first let me put it. This dot this is, remember that you just need to multiply the each component in the each component, that is this times this times this, and this times this. So you multiply the components in x, the components in y, and the component in z in order to get the x, y, and z, let's say, multiplication, and then you add them up. So we will have partial derivative of the function x, y, and z. So that is the partial derivative of the x component of the vector v with respect to x, this times this, plus the partial derivative of the function j, x, y, z with respect to y, this times this, plus the partial derivative of h of x, y, z in the c, or with respect to c. So in this example, the divergence of the vector v will be, this is the partial derivative of 2x plus y with respect to x. Remember that when we take the partial derivative, we take as if the variables that are not with what we are taking the derivative with respect to, we take them as a constant. So partial derivative of 2x plus y with respect to x is 2. Partial derivative of 3 square y plus c with respect to y is 6y. Partial derivative of 8c plus 2 square x with respect to c is 8. So this is the divergence of the vector v, and this is a way of how to pass from the vector to a function. Now this is just a function. So divergence passes from a vector, or converts a vector to a function. Gradient converts a function into a vector. And the gradient is nabla times the function, and the divergence is nabla dot a vector. And the divergence just means how is x spreading the vectors in some vector field. We'll talk about this in future videos, and some integration theorems involving vector fields, etc. In the next video, we're going to talk about the curl of a vector.